We've all heard how AI is going to take over everyone's job, and we need to build a gazillion new data centers to house our new digital overlords, or we'll fall behind. And the amount of electricity to power these cities of silicon and copper is absolutely staggering. And to feed these beasts, nuclear power plants are being restarted, and new nuclear power plants will be needed. Or maybe we can power them with renewables. But you're not being told the truth, which is dirtier than you'll read in the press releases. Today on Decarbonize, we're going to talk about a loophole in America's energy system that developers are using to build these data centers fast and dirty, something called behind the meter. Let's set some background before we dive deep. Data centers can do lots of different things: host YouTube videos about decarbonization, support remote working through tools like Zoom and MS Teams, and store your photos so you don't lose them even if your house burns down, and lots of other things. But for the sake of this video, I'm going to focus on one use: artificial intelligence, or AI. We have enough data centers for all these other uses, but AI is just insatiable in its demand for computations. So, for the sake of this video, a data center is a building with specialized computers that do one of two things: train AI algorithms or use those algorithms to answer a question, which is called making an inference. An example of an inference would be you put a prompt into Midjourney and you get out an image. AI is nothing new. It's just a very clever combination of linear algebra and calculus that allows us to train algorithms to make inferences. In the past, we've used terms like machine learning or neural networks to describe these algorithms. These systems work best when you have a data set that covers the possible input and you know the correct answer for the input data. My first job was working on a device that scanned pap smears and used what we called then a fuzzy classifier to identify cells that suggested the patient might have cervical cancer. In those days, we needed a rack of special chips designed just for us in each machine, and we had a team of cytologists who would capture the images of pap smears and identify cells that were problematic. And from this, we could train our algorithm. The chips have gotten cheaper and faster. The algorithms have gotten more sophisticated, and we have more tricks on how to efficiently train them. We've also gotten better at being able to ask questions that aren't in the training data sets, which is how generative AI tools like ChatGPT work. AI has lots of problems, like hallucinations and using copyrighted material for training without permission, that I'm not going to get into. If you ask me, the value in AI is where it's always been: solving problems that are well defined with a curated data set that can be provided for training. Generative AI can create a lot of output, but it's low value. People with 6 fingers, documents that sound like a legal brief but reference cases that never happened, or deep fake porn videos. As a person who spends too much time on YouTube, I've come to hate AI slop, low-quality AI videos created for YouTube. I wish I could exclude them from my feed. Do you hear me, YouTube? Can you help a brother out? Can you make it so that I can filter on that? Anyway, back to the AI data centers. An interesting thing about a data center is how one expresses its size. You'd think they'd use something like floating point operations per second, but they don't. Data centers are measured by the electricity demand. They're listed in megawatts and even gigawatts for the largest ones. So if you have any doubt of the importance of energy when building and operating a data center, you can put that to rest. If you install more energy efficient computer chips or cooling, the rating of the building stays the same. You just get more computations done, so presumably more revenue. In this field, revenue is a touchy subject, as there isn't much of it. In 2025, OpenAI pulled in $20 billion in revenue, which doesn't sound shabby at all. But they're spending about $1.4 trillion building out data centers over the next 8 years. So in that context, 20 billion isn't very much. That's why many are saying there's an AI bubble, and I'm inclined to agree. I suspect that the bubble will pop before many of the data centers currently planned are built, but many will be built. So how that's done and how they're powered is very important. That's what I'm going to discuss. If you build a house or an office building or a factory, one of the things you need to get is a connection to the grid. For a home, that's usually not a big deal, but for a large consumer or generator of electricity, like a factory or a power plant, getting a grid connection can take years. The grid operator needs to make sure the transmission system can handle the power you're moving. If you're a customer, the operator also needs to make sure there's power available to meet your needs without bringing down the grid. And this is the problem for data centers. They can't get a grid connection. 70% of the internet traffic flows through Data Center Alley in Virginia, and an interconnection there can take 7 years to get. And the data center developers aren't willing to wait that long. They don't even want to wait 7 days, but 7 years is a non-starter. So what are their options? They can build elsewhere, where the queue is shorter, which is driving development out of Virginia to places like Phoenix, Arizona, and San Antonio, Texas. But a grid connection in these places can still take years. So can they build a data center with no utility connection? A homeowner with solar panels on a sunny day can power their home during the day with no electricity flowing through the meter. The panels are behind the meter, which represents the connection to the regional grid. If you add a battery or a diesel generator, all of their power could come from behind the meter, in which case a grid connection isn't needed. That's what data center developers want to do, to disconnect completely from the grid and get all of their electricity produced on site, or at least reduce the amount of power they need for their connection, easing the process of getting approval. A good example of this is the Citadel, a data center near Reno, Nevada, owned and operated by Switch. The site has a large amount of on-site solar and battery storage, reducing the size of the grid connection needed. Through the grid, they can access geothermal, solar, and wind power, augmenting the on-site generation. As far as I can see, this is not greenwashing, but how responsible data centers should be built. Unfortunately, Switch is an outlier. To look at a more typical data center, let's look at Elon Musk's Colossus for his AI company xAI, creator of the much maligned Grok. This is a 150 megawatt data center built in Memphis, Tennessee in only 122 days. They were told it would take 24 months to build. So how did they get it done so fast? One issue was the nearby power plant could only deliver 1/3 of the power needed. So they trucked in methane-powered generators without emission controls that were designed for temporary or emergency use. The generators are much less efficient and dirtier than any methane-powered generator that a utility would install. xAI claimed that since those generators were still on flatbeds, they were temporary and didn't need permits. This could only happen in the US thanks to fracking or other countries where methane or natural gas prices are low. A court disagreed after a lawsuit from the neighborhood activists who were suffering under the air pollution that these inefficient and dirty generators were putting out. xAI claims to have replaced the generators with cleaner ones. In addition to air pollution, these generators, even the new ones, produce a lot more greenhouse gases than a state-of-the-art combined cycle methane-powered generator that a utility would install. But let's get to that $500 billion gorilla in the room, OpenAI. The scale of OpenAI's Stargate project is just breathtaking, with a plan to build $500 billion of data centers in 4 years. The first phase went live in December 2025 in Abilene, Texas, and requires over 200 megawatts of electricity, which is about the power required for 100,000 homes. The local grid couldn't provide that much, so most of it will come from low-efficiency methane-powered turbines placed behind the meter, similar to what Musk is doing in Memphis. In a press conference, Sam Altman CEO of OpenAI, said,
arc of society is that technology creates problems, and then technology plus human ingenuity together is how we figure out how to solve them.
And for climate change and air quality, OpenAI is definitely going to be a problem. I'm not sure if they will ever make things better. Altman is aware of this and is an investor and chairman in Helion, an interesting nuclear fusion company that I've done videos on, and Oklo, a nuclear fission company that is valued at $10 billion despite having never delivered a watt of power and not having submitted a completed design to the Nuclear Regulatory Commission for review. The problem with Altman's plan for nuclear-powered AI is that none of it will be ready to scale for at least 5 years, if ever, which is how long they think it'll take to build the data centers they're planning to build. They claim nuclear power will be ready sooner, but neither of these companies have ever built a commercial power plant or even a pilot plant that produces more energy than it consumes. In addition, we have no idea how expensive the electricity from Helion or Oklo will be, but the company we can compare them to is NuScale, who has the only small modular reactor design that is licensed by the Nuclear Regulatory Commission. And the power from their reactors is so expensive that no one is contracted to build one yet. And I'm willing to wager that neither company will deliver power for any of the $500 billion worth of data centers they're planning. And like Switch, OpenAI seems uninterested in using the sun, wind, and batteries to power their data centers. The growth curve OpenAI is planning is so fast that they can't build high-efficiency methane power plants fast enough since they're back-ordered. So they're scrounging up old jet engines, which are inefficient and dirty. With the big money behind Altman and Musk, AI data centers are poised to reverse all of the progress we've made in decarbonizing the grid. A study by Clearview, link in the description, studied 45 data centers in the US with a combined capacity of 56 gigawatts that planned some portion of their power coming from behind the meter. For scale, this is about 5% of the total generation capacity of the entire US grid today. The CleanView study identified 50 gigawatts of new behind-the-meter methane power plants. For comparison, the total additional capacity added to the grid in 2025 is just 63 gigawatts, which includes power from data centers that are getting power from the grid. Most of the grid-connected increase is solar, followed by wind and batteries, while the vast majority of behind-the-meter grid power is from methane. It does make sense that the grid is focused on solar and wind, while behind the meter is much more focused on methane. If you're connected to the grid, you don't care if your power comes from a wind farm to your east or one to your west, or a solar farm to your south. So grid operators can get power from where the wind is blowing or the sun is shining as long as there's transmission. And if not, then they go to the batteries. But if you're not connected to the grid, you only get power from one solar farm, so you're much more impacted by the weather. And you know you won't get any power from your solar panels at night. That means you need many more batteries and backup power. I believe, as many do, that the AI bubble is going to burst, just like blockchain and subprime mortgages. This doesn't mean that AI is going to disappear, only that applications that don't add real value are. Because of this, it's not going to grow nearly as fast as Sam Altman and Elon Musk say it is. And we can build out the grid and develop data centers like switches in Reno. Once the bubble bursts, that's what's going to happen, but not until the damage is done to the environment, climate, and the broader US economy. So the sooner the bubble bursts, the better. Just like all bubbles, the faster we take the air out of the bubble, the less damage it does. My advice is to oppose any data center proposed in your community that is using inefficient and dirty gas generators like OpenAI's and XAI's. Oppose any special deals like the 85% tax abatement that OpenAI got in Abilene. And I would look at my investment portfolio for companies that are exposed to this bubble, because popping the AI bubble is going to take down at least as many companies as subprime mortgages did. Just in case it's not clear to you, I'm not an investment advisor, so take the financial advice with that warning. Also, like all bubbles, it's hard to time when it will burst. So you could make a lot of money if you time it right, which I can't help you with. I just hope it pops soon. But until this bubble pops, we're all being put at risk from the pollution used to power these data centers. Leave me a comment and share your thoughts. I got a lot of comments on my last video about Helion, and it was great to engage with my viewers, even those who disagree. You can support my channel by buying me a pint or watching more of my videos on the electrical grid. And please share this video with everyone you know who finds generative AI images a bit creepy.